Now here we're looking at various ways of solving quadratic equations. Here you see your textbook refers to what we're about to see as the zero factor property. That's just a fancy name for factoring. So we want to factor the quadratic equation. Now not all quadratic equations are factorable. So this is somewhat limited in its applications. However, I'm looking at this and I'm thinking in order to factor this, I need two things that multiply to give a 10. That's either 5 and 2 or 10 and 1. How about if I start by trying the 5 and the 2? I'm looking at this and I'm thinking there's only one way of getting 2, and that's 2 times 1. Now I can put the 2 in the first spot here and the 1 over there, or vice versa, and it matters because the two different numbers on the x's. So I want the combination that has a difference of 1. In other words, when you subtract, you get a 1. So let me just show, what if I put the 1 here and the 2 here? I need this product, 5 times 2, and this product, 2 times 1, to subtract to give a 1. Now that doesn't work. 5 times 2 is 10. 1 times 2 is 2. That does not subtract to give a 1. So how about if we change these into the 2 here and the 1 here? Now this is 5 times 1. This is 2 times 2. Now 5 and 4 do indeed subtract to give a 1. So that is the correct combination. And we finish it out like this. The minus sign in this spot tells me I have to have opposite signs in the middle. And the plus says I need a plus on the larger product. The 5 times the 1 is the larger product, so the plus would go there, minus there. So now this is where it gets its name. The zero factor property tells me, since this is equal to 0, I take each one of these and set it equal to 0. And finish solving. Notice we come up with two different answers. When we have a quadratic equation where the left-hand side consists of the square of our variable or stuff involving the variable, then we can solve it according to the instructions here by doing the square root of both sides. So when I do the square root of both sides, I've got to remember to put plus and minus. That's a rule. I think I explain why in the future, but not right now. The left-hand side, the square root of x squared, is just an x. Square root of 29 does not simplify. So our answer is x equals positive square root of 29, x equals negative square root of 29. Notice, again, two different answers. Same technique. We're going to do the square root of both sides, put plus and minus on it. The left-hand side comes out to be just x minus 8. On the right-hand side, we can write 24 as 4 times 6. We can do the square root of 4 and square root of 6 separately, and that simplifies to 2 square root of 6. So this would be plus or minus 2 square root 6. Now we get the x by itself by adding 8 to both sides. Now be careful on the adding here. The 2 square root of 6 cannot be changed, and we have 8 added to that, which comes out looking like this. 8 plus or minus 2 square root of 6. Now there is a separate video that explains where the quadratic formula comes from. However, the quadratic formula assumes that our quadratic equation looks like this. And the first order of business is always to make the right-hand side say 0, which means for the problem that we have, we begin by subtracting 3 from both sides. So we've got x squared plus 6x minus 3 equals 0. So you got to have the equal 0 before you can even apply the quadratic formula. Now in the quadratic formula, the value of a is the coefficient on the front of the x squared. Now nothing there means that the coefficient is a 1. I'm going to write that down. The b means the coefficient in front of the x. And the c means the number out by itself. Now use the sign with the number. The quadratic formula goes like this. We've got negative b square root b squared 4ac 2a. So we want to replace all the letters with what we just wrote. Now the negative sign in front of the b stays there. Then we need to replace the b. So get in the habit of using parentheses for all your letters. And then substituting the numbers in their correct spots. Now, when you do the calculations, start here. Negative 6 is just negative 6. Then do what's inside the square root. The 6 squared is 36. Negative 4 times 1 times negative 3 is positive 12. So 36 plus 12 comes out to be 48. When you get to this spot, go ahead and do that multiplication. When you get to this spot, the question becomes, so what about this radical here? Square root of 48 is not a nice number, like a 2 or 3 or 4 or something like that, but we can simplify that. We can rewrite the square root of 48. I'll do it over here as the square root of 16 times the square root of 3. Square root of 16 is a 4. So square root of 48 is the same as 4 times the square root of 3. We can do some simplifying. Negative 6 over 2 and 4 square root of 3 over 2. This would come out to be just a 3. These can be put together, and that's what our answer is going to look like. Now, in this one, we're trying to solve this equation for the r. Now, in looking at it, I can move everything except for the r squared to the other side. So this is similar to the second technique I showed you. If we multiply both sides by 3, we get 3v equals pi r squared h. Those 3's will disappear. If we divide both sides by the h and the pi, we're left with r squared and 3v over pi h. And so to get the r by itself, we just did this earlier, we need to do the square root of both sides, and as they put right here, remember the plus and minus. So we come up with r equals plus and minus 3v over pi h. There's no simplifying to do. So in this one, we're trying to solve for the y, which we see here and here. Since we don't have just a y squared like in the previous problem, we need to use our quadratic formula. Unless, of course, you know how to factor this with the m's and the n's and the p's, which I kind of think you don't. So we'll start by subtracting the 3p from both sides. Remember, the right-hand side has got to say 0. So this comes out to be a 2m y squared minus an n y minus a 3p equals 0. Now, the quadratic formula, I'll just write out the blank version here. And again, you can look at your formula sheet and write out what I'm about to write straight off of the formula sheet. So the quadratic formula says negative b plus or minus square root of b squared minus 4ac over 2a. So here in the first box is b. Now b is negative n. So in the first box, we're going to have negative n and negative n. This is the a, and a is 2m. And finally, the c is the entire thing out to the right before the equal sign. Now again, you want to be careful about handling this, but we do need to do at least some simplifying. Here, the two negatives make a positive n. Inside the square root, we've got a negative n in parentheses squared, which is indeed just n squared. The negative in front of the 4 and the negative in front of the 3 makes a positive. Negative times a negative makes a positive. And we can put the numbers together. 4 times 2 is 8, times 3 is 24. Now there's no simplifying that can be done on that. And then on the bottom, we've got 4m. So that's as far as we can go, and that would be the answer. Now these last three problems are referring to the thing called the discriminant. The discriminant is the part under the square root in the quadratic formula. Here's our quadratic formula. And the stuff that's under the square root is called the discriminant. So we're going to take the b squared minus 4ac all by its little self and substitute. For our problem, the b would be negative 12 and so we come out with the negative 12 in parentheses squared, which is a positive 144, and 4 times 4 times 9, which comes out to be a minus 144. 144 minus 144 comes out to be 0. Now, if you look at the choices up here, we want to know if we have rational roots, irrational roots, or complex roots. If the discriminant is 0, we come out with negative b divided by 2/8. That's a rational number. So a discriminant of 0 means, the 3 dots means therefore, that we have a rational solution. As a matter of fact, we have rational solutions. Remember, the two solutions. Here's, again, to use the quadratic formula, we first have to fix this to 3x squared plus x plus 5 equals 0. Now, the b squared minus 4ac comes out to be 1 squared minus 4 times 3 times 5, which comes out to be 1 minus, whatever in the world 12 times 5 is. I think that's a 60, or negative 59. Now, if the discriminant is negative, then we have complex, because we're doing the square root of a negative number. Finally, when we put this in standard form, and do the discriminant, we get negative 6 squared, which comes out to be 36. Negative and a negative makes a positive. 4 times 2 times 7 is 56. That comes out to be 92. And again, in the quadratic formula, we would be doing the square root of a 92. So we would come out with some number plus or minus the square root of a 92 over some number. That is irrational.